and the operator had disposed of it inside the mine without permission. In 2010...
How would they even let you in there? By popular demand, we are checking out a video by DW Planet A called Germany's Hidden Nuclear Waste Dump. And here we see the infamous yellow barrels. For those of you who don't know me, I'm Tyler Folse. I'm a nuclear engineer, a little over 10 years of experience in the commercial nuclear power industry. From engineering to operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge. Let's check this out.
Only 13 meters below me is radioactive waste that has been lying around here for decades. This former salt mine contains over 100,000 barrels of radioactive trash.
100,000 barrels. That's quite a bit.
And for over 30 years, water has been pouring in.
Okay. Wow. Lot to unpack there. So, barrels. You would not use those for high-level radioactive waste. High-level radioactive waste is stuff like the spent fuel. Those you use something like this, or dry cask storage. Each one of these are over 150 tons, and yes, it is safe to stand right next to them and get minimal amount of dose, because they are very thick with concrete. And this is after the high-level waste, the spent nuclear fuel, has decayed in the spent fuel pool for 10 to 20 years, long enough for their radioactivity to go down significantly. And these structures can withstand severe weather and even direct missile strikes. So these things are quite safe. If these things were down in a pit, they would be fine. Though these are stored on a pad at the surface. They're not going to be underground. At least the ones at the plant that I worked at. There are some long-term repositories where these can be transferred in, but they're perfectly safe on the surface. Now, the barrels that are going to be underground are going to be, or should, I guess I should say, because I don't actually know this event, low-level to intermediate-level waste. But they mentioned decades. Barrels are more of a transient solution, not decades. So low-level waste would include stuff like contaminated protective clothing that a lot of workers wear, like gloves and coveralls. And those can effectively be taken care of by doing nuclear laundry. Other low-level contaminated tools, filters, those sort of things can be compacted to reduce their size so they can be contaminated. Paper and rags can be incinerated. Though a lot of tools can effectively be decontaminated and reused again. Low-level waste is over 90% by volume and is typically dealt with in those measures, not stuck in barrels for decades. Then there's intermediate level waste, things like reactor coolant filters for the water chemistry and cleanup system for the reactor coolant. Those are going to be higher levels of radiation than, say, filters and systems that are further away from the reactor. A lot of things involving intermediate level waste can be stored and just a matter of waiting for some of the stuff to decay away. But in other cases, you can encase them in cement to add layers of shielding. You could encapsulate them in resin or glass. I've never seen that at the plant that I've worked at, but it is a valid method. And liquid waste can be dried in order to reduce the volume. That is probably the most common intermediate level waste I've seen. You would put them in essentially waste holdup tanks for them to be dried, processed, treated, and over the course of several days, they will reach a low enough level that they can be safely discharged back into the environment, because after the treatment and the processing, it's effectively just water you're sending back out. And these samples, any sort of liquid effluence is a big deal. So chemistry technicians need to have the right certifications. They need to use independently verified samples. After all, you don't want to screw up your sample numbers. And they are also done under radiological work permits. Radiation protection technicians are involved. And this is heavily regulated by the Nuclear Regulatory Commission, at least in the United States. records are kept for the lifetime of the plant, plus additional time. So this is something that is very heavily documented, and to me, hearing something about a waste problem for decades is quite surprising. But while I'm not familiar with this event, I think a lot of it comes from earlier time periods where this rigorous record making and qualification process hasn't been fully established yet. Let's see if I'm right.
The shafts and chambers are unstable, and the waste needs to be taken out ASAP.
So they mentioned about water getting in. So that's bad for a few reasons. One is those barrels, since they weren't built for long-term storage, they could come into contact with the water, become corroded. Some of the water could even filter in because it's not like those things are 100% leak tight. And the water itself, if it becomes into contact with radioactive waste, it's no different than any other hazardous material, and that the water itself becomes radioactive waste, becomes hazardous material. So if you thought 100,000 barrels was bad, it's incredibly bad. But if you're going to add an inundation of water seeping in, that's going to make it even worse.
But despite decades of promises to clean this nuclear mess up, not a single barrel has been removed. So how could this have happened?
Great question.
And what's Germany going to do about it? We're headed towards the center of the country, close to the former border between West and East Germany. This entire area has a lot of salt underground. People here used to live from farming for centuries, until a big salt mine opened around 1900, transforming the area. 3 shafts were dug out. Mining continued up to 1964, when it stopped being profitable. Around the
So they're just going to chuck it all in a borehole or something. Okay.
same time, West Germany was looking for a place to store radioactive waste that had started piling up from the growing nuclear industry. That's when all eyes settled on this particular salt mine.
600 meters, turn left onto K513.
We're getting an exclusive tour of the site. Annalena Zimmermann works for the operator of the mine and is taking us underground.
See what kind of PPE.
And we're ready.
Okay, so hard hat, not sure if her glasses are safety rated, and she's not wearing gloves, at least not yet, so probably not a contaminated area. You would wear coveralls and gloves over your regular clothes. A lot of people actually do wear scrubs during outages when you go into contaminated areas more frequently, at least in the nuclear plants.
Die ganze Zeit.
Das misst also die Radioaktivität.
Falls was da wäre, dann würde das Gerät ausschlagen.
So yes, dosimeters measure your dose, usually in millirems or microsieverts. Some dose equivalent, it does the conversion factor for you to see how much dose you have. That's different from a typical detector where it measures a dose rate in the area. Now this thing does measure it, but typically the display it gives you is how much dose your body has received. And usually you wear them on the upper body, around your chest or a pocket in order to get its most accurate reading. They typically have a couple of alarms that go with it. One is if it senses a high dose rate, or 2, if you've gotten more dose than you're anticipated. These alarms are adjustable. If you've seen in some of my videos before, a high alarm does not mean you're in mortal danger or anything like that. It's typically set by the radiation protection technician for the individual job. So an alarm means radiation protection is notified, and get out of the area where the high dose is and get with them to see if there's anything unexpected in the area. But you can set it for pretty low dose rates that you're fine. It's really just a precaution to make sure that you're not going into anywhere unexpected.
This is our oxygen in case of emergency.
Now, oxygen, only seen that when going into confined spaces. I mean, they're going into a mine, so that makes sense. I've never personally carried emergency oxygen, but I mainly worked in open areas of the plant and in the control rooms. So while I was trained to use oxygen and don SCBA in case of an emergency. I've never actually entered a confined space that warranted the use of it, but it makes sense given where she's going.
Not the best feeling to have to be this prepared.
Okay, I'm not sure what her background is, but if you're going into most industrial settings, it's good to always over-prepare. And she's not wearing the respirator, the oxygen immediately. It's just good to have it near you just in case. So it's a bit of a weird statement to me.
Between 1967 and 1978, around
Okay, I had a feeling it was a while ago. So 1967, 1978, this was before 3 Mile Island, the most infamous accident in the US, and Chernobyl, the most infamous accident, period, as far as the nuclear industry is concerned. And while those accidents were bad, the lessons learned helped shape the industry into the heavily safety-conscious environment we see today. So, not to say there weren't accidents that existed before 1967. I've talked more about several of those in other videos, but they weren't as culture-shaping as 3 Mile Island or Chernobyl.
126,000 drums of low and intermediate level waste were brought here into the Asse II mine shaft.
Okay, that makes sense. That makes sense. You would never, even back then, never put high-level waste into something like that. Well, one, it wouldn't fit in those barrels because most fuel assemblies were simply too long. So even if you're doing poor radiological work practices on purpose, things that you would get fired for in a heartbeat today, you physically can't get those into things of that size and shape.
Most of it is waste from nuclear reactors, like filters or construction material. A small part is waste from research and medical facilities.
So a lot of medical facilities, just by volume, you don't need like the massive filters, the things that you have constant use of in a nuclear power plant. But what kind of decontamination stuff did they have locally at each of these individual sites? You're very rarely transported off-site, at least within the US, to other locations. I mean, you mainly see it transported from the research and medical facilities, but power plants, a lot of it is treated on-site. But I mean, this is several decades worth through more questionable radiological waste practices. So I can see how they got there looking back, but as someone who went through my university courses plus all of my intensive industry training that I've received in the 2000s and 2010s, plus refresher training, this is all just wow. It's kind of unfathomable for, I guess, someone who's gone through these programs a lot more recently than the 1960s and 1970s.
But the Asse also contains some uranium and plutonium. All of the waste was stored in 13...
Contains uranium and plutonium, presumably from research. Because fuel, you're not going to get there. But by the way, uranium and plutonium, as far as the high-level stuff that you'd get from nuclear waste, that's not the part you're worried about. It's stuff like cesium-137 and strontium-90 that are way more reactive and are a lot more hazardous and give you a lot more dose per fuel assembly. So, in fact, the uranium in fuel assemblies or plutonium, if you happen to be a plutonium-heavy reactor, those are not particularly hazardous. Well, for one, they're encased in the cladding, and those typically undergo alpha decay, which is caught almost completely by its zircaloid cladding. You can touch those fuel assemblies with your bare hands, unshielded by water, in fresh new fuel that has never been fissioned. It's the fission products that are the hazards and why it needs to be secured and handled safely underwater to prevent the operators from getting high dose. But the fuel itself, you can touch it. I mean, you wear gloves to touch it, but that's really just as much of a hazard as you damaging the fuel assembly, more so than the assembly damaging you. So uranium and plutonium, if it's not within the used fuel, isn't considered high-level waste. Now, if there's large quantities of it, it's considered special nuclear material in that it's material that could conceivably be used to make a weapon. I mean, good luck sorting essentially through the garbage to find supplies to make a weapon. That's incredibly difficult to pull off, but if it exists in sufficient quantities and is isolated from the rest of the waste, and then yeah, you have special nuclear material, which could exist in certain research configurations, depending on what type of research is occurring.
Chambers marked here in red, and it's all still lying around today. Oh my god, it's so windy! Oh. I need to hold on to something. Woo!
Es kommt ja jetzt wahrscheinlich ein bisschen Druck auf die Ohren. Einfach ein bisschen kauen, schlucken und dann geht das
Okay, so they're going deep, deep underground into a mine.
schnell weg.
You can feel the pressure on the ears.
Pretty fast-moving lift. I've never been down in one.
It's really warm, actually.
Also wir sind jetzt gerade hier auf der obersten Ebene ausgestiegen. 490 Meter Sohle ist das.
All of the waste was
Upper is
transported
490
down in
meters.
this elevator. Das ist alles reines Salz.
Genau, alles reines Steinsalz. Also das ganz normale Salz, was man im Salzstreuer in der Küche hat.
Okay.
Ja.
Nur dreckiger.
Yeah, I wouldn't recommend scraping some of that off to season whatever you brought for lunch.
That looks really scary.
Also, another thing about lunch, would not recommend eating in a radiological controlled area. I mean, that's the whole point. It's controlled, as in no eating or drinking. Or the worst part is no bathroom. So hopefully they went before.
Actually. For our first stop, we're getting as close to the nuclear waste as possible.
Presumably within radiologically safe practices. But I hope that's what they meant.
Das hier ist jetzt die Beschickungskammer. Beschicken heißt nichts anderes als einbringen. Also hier drüber war ein Kran, dann kamen die Abfälle, dann konnte man hier diesen Schacht praktisch öffnen und die Fässer konnten...
Just these little tiny boreholes that they just bring them on in. Yeah. Just looking at that, these are some pretty small barrels, at least compared to, say, fuel assemblies or dry cast storage.
alle einzeln durch diese Bohrung eingebracht werden in die Einlagerungskammer, die sich direkt unter uns befindet.
Also direkt unter uns?
Genau. Direkt unter uns ist vermutlich dieser höchste Punkt da vom Kegel.
These barrels were regular metal, not made to hold in radiation. Many may have been damaged while being brought in, and it's unclear how radioactive the
Wow, hopefully not. And they just drop them into a pile. They don't at least try to organize it or have them even stand upright. The irony of this is with radiological waste, since a lot of it's going to be like contaminated equipment and stuff, them dumping on top of each other might actually be safer than throwing in like hazardous chemical waste, because especially if they're as disorganized as this, you know, maybe something leaks into something that could react with something else and release some nasty gases or explode. Or this is just a mess, though. This big pile. This looks like an artist's rendition, so it's possible this isn't accurate, but just a big pile. They couldn't even stack them up and organize them.
Side of the chamber actually is. Also wir stehen hier 12, 13, 14 Meter über den Abfällen und man merkt hier gar keinen Ausschlag, oder?
No, it's low level.
Also da ist ja wirklich, man sieht hier 0,000.
That's precise. So microsieverts, 0.1 microsieverts is eating a banana. So this is a detector like this that is bottomed out. Yeah, they're getting less than nothing.
Mikrosievert. Das kommt wirklich dadurch, dass halt dieses Salz so eine gute abschirmende Wirkung hat. Also hier unten sind wir gerade weniger Strahlung ausgesetzt als über Tage in der Infostelle.
That's true because you're underground. As far as salt being shielded, it's not a bad choice. It's dense material. That's the reason why lead is so effective, is because of its ultra high density, but salt is pretty dense too. They're deep underground, so there's a lot of it, as well as just rock, the earth itself, soil. It's a stable chemical. Has high plasticity. It can essentially self-seal its fractures. So of all the spot to be disorganized and throw a bunch of radioactive waste in. It's not the worst location for that, but the fact that this isn't monitored, isn't tracked, haven't gone through actual disposal methods, it just seems like an afterthought. That's all not good.
Da hat man kosmische Strahlung, aus dem All, terrestrische Strahlung, also von der Erde. Da hat man irgendwelche Gerätschaften um sich rum. Überall kommt eigentlich Strahlung her, also natürlich vorkommende Strahlung. Und hier unten wird man komplett abgeschirmt durch das Salz.
They're probably getting more dose just from standing next to each other, because humans are even slightly radioactive. It's not very much. Cuddling your spouse in bed every night for about a year will just give you a few bananas worth.
Salt also conducts heat well, meaning that warm radioactive waste can cool down without damaging the salt wall significantly. On top of that,
So the amount of decay heat you get from this sort of stuff is not very much compared to, say, the high-level spent fuel pool, where they need to decay in water and then undergo forced helium drying to essentially get them nice and stable in dry cask storage. Here, the thermal part is a lot less of a concern than the dose or the contamination. Really, the biggest thing I see with this is the contamination, because it can just come into contact with other things that are not radioactive waste, thereby making them radioactive waste.
To rock, it can expand and flow, sealing and filling cavities of its own accord, making it hard to permeate. So, great in theory, if there wasn't this not-so-tiny problem with the water. Because the biggest problem
it's the problem with everything underground, putting any asset underground.
has is that there is a lot of water that's leaking into the tunnels. There are more than 500 leaks in the mine. The Asse, including the chambers with radioactive waste, could fill up with this water. To stop that from happening, the operator BGE is collecting it. We're headed to the main water collection point inside the mine.
Dann sieht man hier oben schon an der Decke, an der Fürste, bergmännisch, da sind so Stalaktiten. Da ist es auf jeden Fall irgendwie feucht. Also von da oben kommt halt diese Flüssigkeit hier runter, dass wir die hier im Speicherbecken auffangen können. Das, was hier jetzt ankommt, das ist vollgesättigte Natriumchloridlösung. Das heißt, das ist Wasser, wo so viel Steinsalz drin ist, dass sich nicht mehr Steinsalz auflösen kann. Das kommt von außerhalb des Grubengebäudes hier rein. Das, was hier jetzt lang fließt in dieses Becken, das ist so ungefähr 90% der Lösung, die generell hier ins Grubengebäude kommt.
Wow.
The fact that there is so much water leaking in shouldn't have been a surprise. The two other mine shafts, Asse I and III, already flooded in 1906 and 1924 respectively and had to be closed. Today, about 12,000 liters of water pour in every day. It has to be checked for contamination.
Das ist nicht kontaminierte Lösung. Das heißt, die lassen wir vom Strahlenschutz freimessen.
So, what about other contaminants other than just the radiological contaminants? Toxicity measurements that they're looking at as well? I mean, I know this is mainly going to be under the German equivalent of the Nuclear Regulatory Commission, but it's one thing I'm curious about.
Und dann wird sie auch nach über Tage wieder abgegeben.
Was ist mit den restlichen 10% des Wassers?
Die kommen an anderen Orten an. Ein Teil kommt auch in der Nähe der Abfälle an. Also das heißt, wir haben auch noch einen kleinen Teil kontaminierte Lösung. Momentan ist es nicht so, dass diese Lösung irgendwie weiter in die Umwelt gelangen kann. Wir können aber nicht sicherstellen, dass das für immer so bleibt. Und deswegen müssen wir die Abfälle rausholen.
Yeah, so of getting the waste out and essentially taking it to a treatment plant is what you need to do. Liquid waste, it needs to essentially go through something similar to the advanced liquid processing system, which is basically what I said earlier, treats the water by both mechanical and chemical means, so filters, resins, chem injections, into a position where it can be more easily manageable, and then ultimately discharged back into the environment after proper treatment and, of course, proper sampling verification practices by their technicians in accordance with standards by their equivalent of the Nuclear Regulatory Commission.
But the incoming water is not the only problem. When the salt mine was operational, nobody thought this would become a storage place for nuclear waste. To maximize profits,
yeah, I wonder how much they thought about nuclear waste in 1900.
Many tunnels were dug close to each other. Safety precautions and support structures were reduced to a minimum to mine as much salt as possible. The pressure of the rock surrounding the salt constantly pushes against the mine and causes cracks.
Oh.
That's why over 90% of the mine had to be filled up with salt and concrete to stabilize it. And also why a total of over 600 people work here to monitor and further secure the mine.
This is a very expensive cleanup that I'm sure, looking backwards, on-site management of the waste could have, especially with the nuclear plants, could have handled this a lot easier. Because now you're making an area a radiological controlled area that never really needed to be one in the first place.
The big question really is, how could this have happened?
Man wollte damals, Geld auch zu sparen, ein ehemaliges Gewinnungswerk
Short-term thinking.
nachnutzen.
Frank Ehrlich heads the Asse Information Center.
Hier kam der Bergbau 1964 zum Erliegen. Es war einfach nicht mehr wirtschaftlich. Und das war genau die Zeit, wo der Bund die Anlage gesucht hat und hat sich dieses Bergwerk hier angeschaut und hat sich am Ende für die Schachtanlage Asse II entschieden. Auch wenn die Entscheidung immer umstritten gewesen ist aufgrund der Geologie, des vergleichsweise hohen Alters schon des Bergbaus und der Gefahr von Lösungszutritten.
The mine cost 800,000 German marks at the time, which adjusted for inflation would be about 2 million euros today.
Wow, only 2 million euro. Yeah, how much is this cleanup? Hundreds of millions? We hit a billion yet?
Seemingly a bargain.
Wusste man das damals schon, als es darum ging, ob man die Asse kauft oder nicht, dass es so mehrere Probleme gibt?
Man hätte es wissen können, man hat es aber am Ende anders bewertet. Aber die Risiken sind auch damals schon kommuniziert worden.
The growing nuclear sector needed a dumping ground fast, so the risks were downplayed. The entire project was supposed to be a quick fix.
Did they really need it? No. During the design of these plants, they needed to accommodate for how to manage the waste on site. That goes into reactor site criteria now. You should never be in a situation where you have so much of a waste product because you didn't account for it. If that was the case, if a nuclear power plant, say, suddenly didn't have a solution or couldn't process their own nuclear waste, they would shut it down. Like if the liquid effluent processing systems were to suddenly not work at an existing nuclear power plant, that nuclear power plant wouldn't be operating anymore until that sort of stuff is fixed and that problem is addressed. Nuclear power is an amazing, beautiful thing, but you have to be proactive with how the waste is managed. And keep in mind, this is all the low and intermediate level stuff. I'm wondering how they handled their spent fuel. I mean, I know how they physically handled it by putting it in spent fuel pools, but I'm just wondering how they got into that situation, since the heavy stuff that goes in the spent fuel pools are the kind that, at least when people bring up nuclear waste to me, that's the stuff that everyone talks about. Though there's still the misconception that used nuclear fuel is in these stereotypical yellow barrels. I don't know.
With little to no thought spared for the long-term consequences. At first, Asse was
You can argue that's the biggest problem with just about everything. People don't think long-term, even decades down the line. I can sort of understand where people are coming from with not thinking of, like, alien language markers for nuclear waste repositories a billion years in the future, because that's a little out there.
declared to only be a research storage facility, used for medical and scientific waste only. The long-term consequences. At first, Asse was declared to only be a research storage facility, used for medical and scientific waste only.
That would make a lot more sense, because they don't generate nearly the amount of waste by volume.
But actually, almost all of the intermediate and low-level waste from West German nuclear reactors was then dumped here. In the beginning, the waste was stacked. But after
So that raises another problem. They'd have to, by not doing it locally at the nuclear plants, you have to deal with the mess of dealing with, like, the Department of Transportation safety requirements, which, I don't know, maybe they weren't nearly as strict back then as they are now, but it would just add another leg for having to manage the nuclear waste that really isn't necessary. And even in certain few situations where you can't take care of it on site, you could cut the volume of it down significantly on site.
After a while, barrels were literally dumped into the mine to reduce the radioactive exposure of the truck drivers. Dump trucks also drove over the waste.
So they had leaky barrels, basically. They shouldn't even be transporting this stuff. That's the other hazard, is they managing it on site. If the dose is really that bad for the truck drivers, they shouldn't be transported at that point.
Damaging many of the barrels. Energy companies didn't pay anything to store their waste until 1975.
Wow.
And we don't even exactly know which type of waste was dumped, because the documentation was very poorly and vaguely done.
So that's even worse. Not knowing what's in each of these things, not knowing what the dose rate is, labeling is probably bad. Maybe this is where those stereotypical yellow barrels have come from, just because that's what people think of when they think of this poorly mismanaged mess.
In 1988, water starts leaking in. Multiple mining shafts collapse, but the public is only informed about the magnitude of the problem almost 10 years later. In 1997, the operator suggests closing the mine with all of the waste inside. The plan does not mention anything about the long-time safety and possible contamination.
There you go, close it up, pretend it's not there, see what happens. That's a good idea.
In 2008, the news breaks that water has been coming into contact with radioactive waste for years. Pools of contaminated water had been collecting right in front of the chambers containing it, and the operator had disposed of it inside the mine without permission. In 2010,
how would they even let you in there? That's preposterous.
It turns out that 10 times more intermediate nuclear waste is stored than was estimated before. Years of political mishaps involving nuclear power prompt protests across Germany. Finally,
so you know what? If this is much, I can understand why there's such an anti-nuclear movement if it's this poorly managed there. I mean, with great power, with great nuclear power comes great nuclear responsibility.
In 2013, the law Lex Asse is enacted. The government decides that the mine is too dangerous and the waste needs to be taken out. And all the while, every newly appointed responsible minister has come and promised change.
Der Staat hat ja auch 40 Jahre zugeschaut.
Es muss schnellstens raus und das müssen und wollen wir schaffen.
Und deshalb ist es auch eine Frage der Glaubwürdigkeit der Politik, dass wir damit ernsthaft und offen umgehen.
But not one.
Look, I was looking at some of those terms. They're pretty quick for. I'm wondering. So I don't know Germany's political cycles, if filtering through this many environmental ministers is common, but I'm wondering if a lot of broken promises have caused their terms to be this short. Please correct me if I'm wrong about that one. I know very little about German politics.
Barrel has been retrieved.
27, 26, 25, 2, 1. Vielen Dank. Keine Kontamination.
That scanner that you go up to is when you leave a radiological controlled area. It checks different body parts for contaminants, whether it be your hands, your feet, your hard head, your chest, your back. There's detectors all around you. There's often various levels of detectors after you're leaving. So there's one when you're exiting the reactor containment building, for instance, in a nuclear plant. You go through something like this, and then you go through another one just before you exit the radiological controlled area. And then there are some more coarse ones you go into even when you leave the protected area of the nuclear plant, basically inside the security fence. Even if you walk through those detectors, even if you didn't enter the radiological controlled area at all, just to be absolutely sure. It's gotten to the point where if you're on any sort of radiological medical devices for any sort of procedure, you need to report that to radiation protection so they know to expect things.
Whew, happy about that. I know there's a lot of stabilization work and so on going on down there, but not the best feeling to be that close to nuclear waste, to be honest.
I can understand that. Nuclear waste doesn't bother me. Mismanaged nuclear waste bothers. So I can understand that just knowing how mismanaged it all was.
The problem is, a big removal like this has never been done before.
Das Erste, was wir machen müssen, ist jede der insgesamt 13 Einlagerungskammern erkunden, um zu wissen, wie ist das umliegende Gebirge beschaffen, in welchem Zustand sind die Abfälle.
Since many of the barrels are damaged, no human can enter the chambers. They have to be surveyed by remote-controlled cameras like this one and retrieved by remotely operated machines. A new shaft must be built to transport the barrels out.
Ja, die Herausforderung ist am Ende.
Depending on how this is, we're talking, and move to another location, we're talking road blocks off, remote operated trucks, depending on what's in each one of those. So they're going to need to optimize the loading of the trucks once they get it out, not only by weight, but by how hot the waste is.
Auch der Berg, der uns ja Grenzen setzt. Das Bergwerk verformt sich weiter. Wir haben den Lösungszutritt, der dafür sorgt, dass hier ja eine gewisse Gefahr im Vollzug ist. Und deswegen ist die Zeit, die uns damit im Nacken sitzt, halt besonders zu beachten. Das Worst-Case-Szenario ist am Ende ein Lösungszutritt, der technisch nicht zu beherrschen ist, sodass wir dann das Bergwerk aufgeben müssten, die radioaktive Abfälle unter Tage verbleiben würden und dann möglicherweise radioaktive Stoffe über lange Zeit wieder an die Tagesoberfläche kommen.
And unfortunately, since, we don't know what's in there, that's a real possibility. Probably how this could is you can remove some once it's been surveyed. You can compact some to reduce the overall volume, but it's possible there might be hot pieces in there. With low and intermediate level waste, it shouldn't be possible that you would have to essentially make a sarcophagus underground in order to prevent those from leaking. But part of me wonders if said intermediate level waste wasn't stored within the appropriate standards and limits of radioactive waste in a certain spot. It's possible things were mixed improperly. So there could be really weird, ununiform, and uncertain concentrations of certain materials in there that might not be able to get brought out. I really hope that's not the case, but it's not impossible to be in that situation.
And even if we ignore that frightening scenario, all of this is going to cost a lot of money. Just preparing for the removal will cost an estimated 4.7 billion euros.
Not surprised. So 4.7 billion euros. That's more than enough to install and upgrade liquid waste processing systems, not just in Germany, but probably in a large portion of the world. That they could have done instead of this. Could even go a long way towards making a new nuclear power plant. That door is apparently shut in Germany, at least for the time being.
And that does not include any of the retrieval itself, which is scheduled to start in 2033. The waste is supposed to be sorted in an interim facility and then transported to, well, where exactly?
Hopefully not just sort it. Maybe by sort it, they also mean process and treat the waste, depending on what it is, to reduce the volume, reduce the radioactivity, not just reallocating it in different barrels.
Brauchen ist ein Endlager für die radioaktiven Abfälle und dieses Endlager haben wir noch nicht, wo wir die Abfälle hinbringen können. Das heißt, wir müssen
Now, at this point, I can understand them not having a final storage place because they don't know what it is yet. That's the big thing that needs to go into it. So I'd say process what you can, evaluate what you can.
Die Abfälle erstmal zwischenlagern. Und das ist der Punkt, der gerade für viele Diskussionen sorgt. Wir haben hier das sogenannte Kuhlager. Das ist eine Freifläche hier auf dem Asse-Höhenzug und nach unseren Planungen würden wir dort gern die Abfallbehandlungsanlage und das Zwischenlager errichten. Das ist unser Plan. Der Standort ist aber in der Region umstritten.
Because the Asse mine isn't in a super remote area. Only about 2 kilometers south of it is the village of Remling-Semstedt, home to a protest group that Heike Wiegel co-founded.
I can only imagine why they're protesting.
Their protest sign is seen throughout the area, and the group rallies together for official political visits.
Es soll ja ein neuer Schacht geben und auch ein neuer Schornstein. Und das sind erhebliche Belastungen, zusätzliche Belastungen für diese Region, die sowieso dazukommen.
The operator of the mine has calculated the risks of retrieval, but in Wiegel's opinion they are deliberately underestimating the danger, and an alternative location for the intermediate storage has not been considered in detail. Nobody knows how long the waste would stay here in the region, since the search for a final storage site has not even started yet.
Es wird ein Endlager gesucht für hochradioaktiven Atome in Deutschland und gleich.
I'm not actually sure where Germany stores a lot of their nuclear waste. As far as long-term storage, so for low-level waste, which would hopefully be most of it by volume, you don't necessarily need the deep underground sites. It could conceivably be done in a relatively shallow land covered with like soil or other materials because it's low level, but we need to figure out how much it's really low level. The intermediate level or the more long-lived low level, that's the stuff that would need to go in deep geological disposal after the volume of it has been reduced and after as much of it as possible has been treated. Because the part of it that's expensive is just putting more and more of the stuff in there, but if you can clean it up, then you wouldn't need it to be as big.
Zeitig wird gesagt, na ja, danach, wenn wir das mal haben irgendwann, dann gucken wir mal, ob wir dort in der Nähe auch den Atome aus der Asse lagern können. Das ist schon ziemlich makaber. Wenn man weiß, dass der Atome zurückgeholt werden soll, dann müsste man auch jetzt schon danach suchen.
Asse shows what happens when you put economic interests before safety.
It's a symbol.
I would even take it a step further and replace that with short-term economic interests, because safety should be at the forefront for all long-term economic interests.
Of a time when nuclear power had to succeed, no matter what, and the long-term consequences of the new technology were largely downplayed or ignored.
In the end, it's the German taxpayers and not the companies or the government that caused it who have to pay for this mess.
If we actually find a location to move the waste to, that is.
Ugh, what a mess. This sort of mismanaged mess is what gives nuclear power a bad name, which is unfortunate because it could have been very easily have gone the other direction if they did it safe. Thanks so much for the recommendation for this video, and thank you so much for watching. I'll see you next time.